The idea is that usually if you measure scores of anything, temperatures, heights, weights, exam results, etc., you're going to have the mean. You're going to have all of the scores clustered around the mean, but then there will be unusual individuals who are either side, really, really far away, separate from the whole body of everyone else, okay? And that's how we describe what outliers are. So if you just, on the side of your page here, if you draw yourself like a really rough sketch of what a set of scores could look like, you might expect a frequency graph to look something like this. By the way, last time, or yesterday, you had a look at some of these shapes and their names. What would you call this? You could call it a bell curve is a very common name, a U-shaped or an upside down U-shaped kind of thing. Well, the one that, this is pretty symmetrical. I'd say it's pretty symmetrical. Yeah, I suppose, yeah, kind of. Does that feel better? Okay. Year 12. In the middle of the scores, as you expect, there's your mean. And then maybe you get like a few guys over here, right? You're like, what's going on there, right? So you would class these guys, let's just change that a little bit. You would class these guys outliers because they fit this informal definition perfectly. You've got this is the big body of scores, and then these guys are separate, okay? But as you can imagine, this kind of definition only takes you so far. Because it's informal, it's like, well, if I've got millions and millions of scores, at which point do I say these people are outliers or not? So that's why we introduce a more mathematical mechanism for this. And I'm actually going to show you. Thankfully, I don't know if this was mentioned yesterday. This is on the reference sheet, okay? So, not the reference sheet, the formulary data sheet. Our mathematical formula for how to work out outliers starts with the interquartile range, okay? So you take the interquartile range, you know what that number is. So that's how far apart what two things are. What do these represent? Yeah, so this is, and you can write this in two different ways. You can say Q3 take away Q1, or alternatively, sometimes instead of the 3 and the 1, what do you see?
U and
Yeah, you see U and L instead of 3 and 1. What did the U and the L stand for? Yeah, good. So I'm just going to write that down here. Okay. So you've got, as you can imagine from here, you've got two potential groups of outliers. You've got people who are above the main body and then people who are below. And you can access both of them by taking this number and seeing how they interact with these guys, right? So let's think about this. If you're below, so this is outliers who are below. Obviously, if you're below the mean, well, you expect like half the people to be below the mean, roughly. So how far do you need to be below the mean in order to be classed an outlier? You have to be pretty far, right? Like you have to be quite a distance away. So what distance is that? We say if you are 1.5 times that interquartile range, right? If you're 1.5, and this is the important number, if you're below the lower quartile by that far, so QL, take away that. Anything below this, you say, well, that must be an outlier down here. The interquartile range is quite a broad number. So to be 1.5 times further away than the lower quartile means, okay, we're really, really down the bottom. Outliers that are above the mean are exactly the same, but in the opposite direction. So outliers above the mean. This means you're not just above average, you're really, really above average. How much above average are you? Well, instead of starting from the lower quartile and subtracting, you're going to go from the upper quartile and you're going to add to go further up. What do you think we're going to add? 1.5 times the interquartile range. Okay. So, as I just mentioned, this is on, these two things here are on the formula and data sheet. So you don't need to remember those numbers, bless you, which I think is helpful because the 1.5 is kind of arbitrary. People just decided, well, that's going to give you a pretty good idea of whether you're too far or you're too close. Okay, so question.
If the number, say like the one for the below one is like 7, does that include 7 as an outlier or is it anything below 7?
Okay, hold on a second. So let's actually can we do an example?
Yeah, what does the number?
Let's actually do an example, okay? I'm going to give you some data here, so get your calculator ready. Another one. Who are you looking for this time? Jess is not here. Yeah, sorry. Okay, I gave you some scores just now. What were they? There's three scores at the beginning. There was like 75,
87,
And 64.
and 64. You guys added on a 95, I think. Okay, now we're going to add on a few more scores to this because at the moment, there being only 4 scores, it's somewhat silly to talk about quartiles, right? There's not much of a population here. The quartiles, well, there's only 4 scores, so it's each of those is a quarter. So let's add a few more scores onto this to make it a little more interesting. So the mean at the moment is 80, right? The mean's 80, so it wouldn't be that surprising that most of the scores are going to cluster around 80.
Actually, the score isn't 80. It's.
Oh, it'll be just a bit above 80, right? Okay.
You want the score to be exactly 80.
Well,
It's
that's-
94.
Yeah, alright, thank you. We've established what the mean is or is not now. So I'm going to add a few more scores onto here just to make it interesting. Okay, there we go. So, let's go ahead. You've got a bit of a head start on me. So let's punch these into our calculator and recall that a lot of you do have the calculator which will work out interquartile range for you, which is very handy. So let's all do that.
I just figured out the mean. That's not what we're supposed to do.
Wait, you didn't want the mean first, and then the median. It's gonna be
Is min and max, that's the. I got 16.5.
You're talking about the interquartile range? Yeah. Cool. Okay, so you're a step ahead of me. So give me a second.
So can you move your hand up slightly? Thank you.
That's, did you say 16.5? Yeah? Yeah. That's good. That's matching what I've got. Okay, so you had a bit of a head start on me. So is this what you're matching? Is this what your calculator is? Yeah, okay. So just to check what's going on and make sure, like, I've given you a small enough set of numbers that we actually can just physically order these and make sure that this makes sense with what we're talking about. What's the smallest score? Looks like 60, then followed by a 64. Are there any more scores in the 60s? No, so you move over to the 70s. 75? 78? Any more scores in the 70s? Okay, now we've got a bunch of 80s, right? So I think I gave you 81, 82, 85, 87, and then 95. Did I miss any? That looks okay? Alright, so let's just quickly have a look. Because there are 9 scores, that's an odd number. You can work out what the median is very quickly. Which one is the median? Out of 9 scores.
81.
It's going to be the 5th score because it's right in the middle. So that guy itself is the median. You've got 4 scores on either side. Now, can you see how they've worked out what the upper quartile and the lower quartile are? Do you see them? 86, where's that? It's right in between these 2 scores. Yes? And what about 69.5? Where's that from? Yeah, it's the mean of 64 and 75. Okay, so everything's checking out. We've just found the interquartile range by subtracting. Okay, now it's not just that number. Yeah, question.
Oh wait, no.
Yeah, you okay? Yeah? Okay, so if this span here is 16.5, okay? I want to know what's 1.5 times that span. So 1.5 times the interquartile range is equal to, what is it equal to? Someone already got it? 20, well half of this is 8.25. 20, 0.75, isn't it? Okay, so in other words, what you've done is you've taken this interquartile range and then you said, okay, now go a bit further. Go a bit further, right? We want to have a comparison about what these numbers are with this set of data. Okay, so let's have a look at this. The lower quartile is 69.5. So to subtract this, 69.5, take away 24.75, that's going to be 44.75 here. 44.75. That's quite low, isn't it? Which makes sense. In order to be really an outlier, you've got to be quite far away from all of these guys here. Okay. In exactly the same way, I'm going to reverse it, go from upper quartile, which is 86, and then I'm going to add 24.75. So that's going to be 110.75? Yeah? Is that okay? Now, I didn't say what these scores were. If they were percentages, this would mean that the scores are so high you can't really have an outlier above, according to this definition, because you can't get more than 100%. But that tells you how far you need to. If these are heights or some other, like temperatures in Fahrenheit maybe, that would tell you how far you need to go to be classified as an outlier. Okay. So does that make sense? See the way it's not hard to work out what each of these numbers is, and then you just have to know what to do with it.
Oh, so that's just showing you what the outlier would be if there was one.
Correct. So I can now answer the question: are any of these scores outliers? And I mean, you could look at these numbers and say, well, this guy's kind of high compared to the rest of them, but he's not really high enough to meet this numerical standard for too high. And it's the same thing with the 60. It's not low enough to be that. If I had scored 43, you'd say, okay, this guy's so much of an outlier. If I put 43 over here, you'd say, well, maybe we should actually ignore him from part of the data because most of the class is clearly over here.